In this example, we put two concepts together. First, the work done by friction takes away from the total energy of an object, and second, that we can calculate the work done by friction given the frictional coefficient and the mass of the object. So we have a book with a mass of 2.15 kilograms. It's given a shove so that its initial velocity is 0.95 meters per second. It slides across a table that has a coefficient of kinetic friction of 0.34 with the book. And the question is, how far does the book slide before coming to rest? Now let's think about the situation here. The book is given a shove, so it has kinetic energy. It's on a level table, so we're just going to ignore potential energy, so the kinetic energy is the total energy. However, friction's going to work on it and start taking that total energy away. Eventually, friction will take all of that energy away, and the book will come to rest. So we need to start by determining how much energy the book has. Well, since the table is level, we're going to ignore potential energy, so the only energy is kinetic. And we know the kinetic energy is 1/2 mv squared. We have m and v, so we can calculate the kinetic energy. The kinetic energy is 1/2 m, 2.15 kilograms, times v, 0.95 meters per second squared. That works out to 0.97 joules. That's the total energy the book has when it starts sliding. In order to stop the book, friction is going to have to remove all of that energy. How does it do that? It does that by working on the book. To calculate the work done by friction, we need the frictional force. So let's calculate that. Frictional force is the coefficient times the normal force. We're on a level table here, so the normal force is equal to the weight. So the normal force can just be calculated with m times g. So the frictional force is the coefficient, 0.34, times m, 2.15 kilograms, times g, 9.8 meters per second squared. That works out to 7.2 newtons. So that's the force that friction uses to slow the book down. We know that the work done by friction is equal to the force times the distance. All right, how much work does friction need to do? Well, to stop the book, friction needs to get rid of all of the energy. There is 0.97 joules in the book when it initially starts, so that's the work that friction has to do to stop the book. So W equals 0.97 joules. The force due to friction has already been calculated, 7.2 newtons, and we don't know x. That's what we're trying to find. So we can solve for x by just dividing both sides by 7.2 newtons. When we do that, newtons cancel, and we're left with meters. That's good because we're trying to solve for distance. And when we work out the numbers, we get 0.13 meters. So the book slides 13 centimeters before coming to rest.